continuing along, let's take a look at what happens when we multiply two negative radicals with the negative on the inside. So let's take a look. First, we've got, let's see, the square root of negative 4 times the square root of negative 9. Well, just like before, we have to take the i's out of the square roots first. So when we take the square root of a negative 4, it actually comes out as the square root of 4, which is 2. And then the negative on the inside comes out as an I. Then we have the square root of negative 9. And again, the square root of 9 is 3. And the negative will come out as an I. So what we actually have is a 2i times a 3i, which is a 6i squared. Now, we were just talking about this a moment ago, but the I squared, remember, is just negative 1. So I've actually got a 6 here times the negative 1, which is going to give us negative 6. Now, this is one of the only times in math where we have two negatives, or what looks like two negatives, multiplied together to give us another negative. But it's because they're not negatives. The i's are, or the negatives are actually representing i's, not true negative numbers. That's why we're able to get a negative number out. So it is set up to look kind of like a booby trap because we need to pull out any i's first. So that should be the lesson of this, is to always pull out any negatives under the square roots as i's first before you do anything. This is going to be true whether or not we're doing it, like in this case, for multiplication. It's also going to be true for division as well. Once we've done the multiplication or division, then we can multiply or divide, but we have to pull out the i's first. So let's take a look at an example. In problem A, we have the square root of negative 17 times the square root of negative 17. So the first thing that we would do is work out on pulling out the i's from the two square roots. So what that would be is that would give us the I coming out of the first square root. We can't take the square root of the 17 though, so that would stay inside. Times the second one also has a negative inside the square root. That can come out as an I. But again, you would not be able to take the square root of 17, so that would stay inside. Then we have, let's see, an I times an I, which would give us an I squared. And we also have, let's see, a square root of 17 times another square root of 17. Remember, when we have two identical square roots, the square roots just fall away and just leave us the number underneath, the 17. So now I can focus on the fact that I have an I squared and replace that I squared with, remember, I squared can get replaced with a negative 1. So I'll have a negative 1 times our 17. Well, negative 1 times 17 is going to give us a negative 17, which if you go back to the original problem does make sense. Two identical square roots multiplied together, the square root should just drop off and give you what's underneath, which is the negative 17. That is exactly what happened. Now let's take a look at B. In problem B, we have the square root of negative 5 times the square root of negative 15. Again, we'll start off the same way by taking the negative out of the first square root. That'll come out as an I. We cannot take the square root of the 5, so it will stay inside. Times, again, we've got a negative on the inside of the square root, so that will come out as an I. And then we'll leave the 15 on the inside of the square root. Then we end up with I times I, which is going to be an I squared again, just like the last one. However, because we couldn't take the square root of 17, they were identical, that we were able to just have the square root disappear. Not on this next one. We've got the square root of 5 times the square root of 15. So what I can just do is my normal multiplication of 5 times 15 is 75. However, they were not identical and we haven't taken the square root yet. So there is still a square root there. Continuing along though, I can, just like the last one, replace my I squared now with a negative or a negative 1. And I still have my square root of 75. The question is, can I break that down any further to help me out? Well, I can break the 75 into 25 times 3 so that I can take the square root of the 70 or the 25. The square root of the 25 will come out as a 5. Let's see. Come out as a 5. And then the 3 will stay inside. However, don't forget that you had a negative or a negative 1 out in front. That means my answer is going to remain negative. So, my final answer here is a negative 5 square roots of 3. And that's exactly how I would type it in. Let's take a look at C. In problem C, we have the square root of negative 70 over the square root of negative 10. So we'd start off the same way. We'd start out with, on top, we have a negative inside the square root that can come out as an I. We'd leave the 70 alone for right now, so it stays as the square root of 70. We can also pull out the negative from the square root on the bottom, so that would come out as an I, and still leave us with a square root of 10. Now, if we had seen, instead of i's, x's on the top and the bottom, like this, we would, without hesitation, cancel them out. And that's what we're going to do here, too. We have an I on the top. We can cancel that out with the I on the bottom. Now we just have the square root of 70 divided by the square root of 10. This is two separated square roots, so what we're going to do is we're going to join the two square roots here instead of doing them separately, putting them together. And we can do that because they're both square roots. So I can, instead of writing this as two separate square roots, write this as one big square root with the 70 divided by 10 underneath the square root. Let's see. So I didn't really change anything. It's just instead of having the square roots separate, we're putting them together. Which means now I can do the division first. I can do the 70 divided by 10, which is 7, first, and put the square root on the outside. Now the question would be, can I take the square root of 7? The answer is no. So that's how I know I am done. My final answer is the square root of 7. Let's take a look at D. In D, we have the square root of negative 54 over the square root of 27. So on top, we have a negative inside the square root, which will come out as an I. And then we have the square root of 54 on the top, and we have a square root of 27 on the bottom. So what we have now is we can do the same thing, except for this time there is only an I on the top. There's nothing to actually cancel it out with on the bottom, so I have to keep the I. However, I can join up the two square roots because we have a square root on the top and a square root on the bottom, and make one big square root and put my division inside of it. The 54 divided by the 27. So let's try that. The 54 divided by the 27 on the inside of my square root. So I've still got my I. I've still got my square root. It's just now my 54 divided by 27 is just I can do the division, it's just a number 2. So now the question becomes, can I take the square root of 2? No, we can't, so this is our final answer. And we're done. In the next problem, we have, let's see, the square root of negative 12 times the square root of negative 6 over the square root of 8. So, let's see. We can pull out the I from the first square root on the top, and that will leave us with I square root of 12 times, I can pull out the negative from the second square root as an I as well. So that'll be I times the square root of 6 all over the square root of 8. Continuing along, now I can go ahead and multiply normally. I've got an I times an I, which is going to give me an I squared. And I can multiply, let's see, the square root of 12 times the square root of 6, which will give me the square root of, 12 times 6. I'm going to bring the two square roots together. 12 times 6 is 72. And I've got the square root of 8 on the bottom. Continuing along, we've got the I squared, which is negative 1. And on top I had that square root of 72. And on the bottom I had my square root of 8. Let's see. So just like we've done in the past couple problems, what we can do is rewrite our two separate square roots as one big square root. So that will be rewritten as one big square root. And we've got the 72 and the 8 that we are dividing. So we've got 72 over 8. And let's not forget that we do have that this answer should be negative because there was that negative 1. So now I can, though, do my division first, which is 72 divided by 8, which is 9. So I've got my negative, my square root, and now I've got a 9 underneath. Well, the square root of 9 we can actually do this time. The square root of 9 is 3. And let's not forget our negative out in front. We've got, so that gives us a negative 3 as our final answer. And we're done.